Right, so I'm going to cover an important area in terms of privacy, and that's to do with zero knowledge proofs. So what are zero knowledge proofs? ZKP, zero knowledge proofs. Well, zero knowledge proofs are all about proving something. So we might have Peggy, the prover, proving something to Victor, the verifier. In this way, Peggy proves something to Victor without Victor actually seeing what the original data was. So with ZKP, we make sure that Peggy doesn't reveal any sensitive secrets. So the core of this is the concept of privacy-preserving knowledge exchange. And in the classic case, what we have is Alibaba's cave. We might draw it like this, and we have a secret passway. And in the Alibaba's cave, we of course have Victor and we have Peggy. So within this scenario, what happens is that Peggy goes into the cave into one of the entrance points, A or B. Victor doesn't see Peggy going in, but Peggy goes in, and then Victor calls out that Peggy should reveal herself through exit A. And in this case, Peggy will do that. And each time, Victor will ask Peggy to appear out one of the entrances, and depending on which one Peggy chooses, she will get it right if she knows the password all of the time, but eventually she will get it wrong if she does not know the password. So for example, if Peggy went through A and Victor asked for B, then Peggy could not appear out of B. In this case, it's really 1 over 2 to the power of n is the probability that 1 minus this is the probability that Peggy knows the secret password here. So every single time that we do it, we increase the chances of Victor knowing that Peggy does know the password. And Peggy does not reveal the password at all when she's doing this. So this is really at the basis of our zero knowledge proofs. Some way that we can actually prove that something is true, or that we know some data without actually revealing it. One of the first papers which actually defined a method to be able to implement a zero knowledge proof method was the Viet-Shamir method. With this, Peggy has a secret value. Let's call that secret value y. Then Peggy will take g to the power of y and mod of a prime number, and we'll call that big Y here. So in this case, Peggy will register with Victor. So we have Victor here, and we have Peggy over here. This is the secret that Peggy wants to preserve, and this is the value that Victor knows Peggy, but will not reveal the value of y because we cannot solve this for the value of y in this case. So now we will generate a challenge. So Victor sends over a value of C in this case, and Peggy will generate a new random value. And let's say that value is X. Next, Peggy will generate a value E, which is the value of X minus the secret times the challenge. And we'll also take that in terms of mod P, but we'll just leave that off just now. So the calculation is the new random value, the Y value that Peggy has a secret, and the challenge